Welcome back, guys. I'm now going to have you guys do a couple examples where we're launching things at angles. And again, this is not a super common thing in AP. Mostly it'll be a horizontal launch, but I would like you to have a little bit of practice with it. All right, a baseball player leads off the game and hits a long home run. The ball leaves the bat at an angle of 30 degrees from the horizontal with a velocity of 40 meters per second. How far will it travel in the air? All right, so when we're talking about how far it's traveling in the air, we're talking about the range. So how far does it go in the x direction? The first thing that you're going to want to do is look at your initial velocity. We have nowhere to put this 40 meters per second in our chart. And so what we're going to do is we're going to resolve it into components. We're going to say I have an x direction velocity, I have a y direction velocity, and we're going to solve for these. So in the x direction, I would use cosine, and I'm going to say that cosine of 30 is going to be equal to v naught x over 40. So v naught x is going to be 40 meters per second cosine of 30, which I think is 34.6, but I'm going to put it in the calculator because I'm not exactly sure. Yeah, 34.6. Then for the y direction, I'm going to do sine. Now this one's going to be our opposite side over our adjacent. And this will be 40 meters per second times sine of 30, which is going to be 20. Once I have those, I can make a chart for my x and y directions. My initial velocity in the x direction is this 34.6. In the y direction, it's positive 20. My final velocity in the x direction is going to stay 34.6 because I have no acceleration. In the y direction, and I'm assuming it's going from level ground because they're not telling me that it's not, it's going to end up at negative 20 meters per second. Its acceleration is going to be negative 10 meters per second. It is going to start in the ground and end up in the ground. So its displacement in the y direction is 0. We don't know its displacement in the x direction yet, but I can solve for the time and plug that in to get that. So I'm going to say that in the y direction, v equals v naught plus at. So v minus v naught over a is t. And so this is going to be negative 20 minus 20 divided by negative 10 is 4 seconds. This is the same for both charts, and so then I can consider the x direction. And my horizontal range, how far it goes sideways, would just be 34.6 times 4. So about 138 meters. All right, a golfer is teeing off on a 170-meter long par 3 hole. The ball leaves with a velocity of 40 meters per second at 50 degrees to the horizontal. Assuming that she hits the ball on a direct path to the hole, how far from the hole will the ball land? So this is not x minus x naught. But we're going to take whatever we get, x minus x naught, subtract it from that to find out how far away we are. So again, start with my arrow, which is 40 meters per second, and what my angle is, and I'm going to find out the two vectors that could replace this real vector that will make it unchanged. One that does the same thing in the x direction, one that does the same thing in the y direction. So cosine of 50 is going to be v naught x over 40. So I would have 40 cosine 50. It's 25.7. In the y direction, I would have v naught y over 40. So v naught y is going to be 40 sine of 50. $30.6. Again, we'll look at our charts. I'm going to have an x direction and a y direction. In the x direction, my initial velocity is 25.7. In the y direction, it is 30.6. In the x direction, this is the same because the acceleration is 0. In the y direction, this is going to be negative. I'm assuming that it's starting on the ground and ending up on the ground. And that's more realistic than a baseball would be, right? Because a golf ball pretty much starts on the ground. My acceleration here would be 0, and here would be negative 10. My displacement here, we don't know. My displacement here would be 0 because it starts on the ground and ends up on the ground. And I don't know the time. So again, I can solve for the time and plug it in. So I'll consider the y direction. So I have negative 30.6 minus positive 30.6 divided by 10. So that's going to give me 6.1 seconds. Then if I plug this in here, I can consider the x direction. And again, my acceleration is 0, so the 1/2 at squared part is gone. So I'm just going to have 25.7 times 6.1. So this is where it's going to land. How far it is from the hole would be 170 minus this. So this would be 13 meters. Which is pretty far. It's over 40 feet.